In this lesson, we're going to talk about the fundamental counting principle, and we will solve problems involving independent and dependent events. How can you count the maximum number of license plates a state can issue? Most states have letters and digits on their license plates. The number of possible plates is too great to count by listing all the possibilities. It is much more efficient to count the number of possibilities by using the fundamental counting principle. An outcome is the result of a single trial. For example, the trial of flipping a coin once has two outcomes, either head or tail. The set of all possible outcomes is called the sample space. An event consists of one or more outcomes of a trial. The choices of letters and digits to be put on the license plate are called independent events because each letter or digit chosen does not affect the other choices. For situations in which the number of choices leads to a small number of total possibilities, you can use a tree diagram or table and count them. A sandwich menu offers customers a choice of white, wheat, or rye bread with one spread chosen from butter, mustard, or mayonnaise. How many different combinations of bread and spread are there? If we look at it as a tree diagram, they listed the choices of bread as white, wheat, or rye, and then butter, mustard, or mayonnaise. And so here are our possible combinations, and it looks like we have 9 of them. Here's the same information written in a chart, which kind of reminds us of matrices. And again, we can see that there are 3 by 3, so a total of 9 choices. And this 3 by 3 scenario lends nicely into the fundamental counting principle. If event n can occur m ways and event n can occur n ways, then m followed by n can occur m times n ways. So if event m can occur 2 ways and n can occur 3 ways, then they can occur together 2 times 3 are 6 ways. For their vacation, the Murray family is choosing a trip to the beach or the mountains. That is 2 choices. They can select their transportation from a car, plane, or train. That is 3 choices. How many different ways can they select a destination followed by a means of transportation? That would be 6. How many codes are possible if an answer machine requires a 2-digit code to retrieve messages? Well, the first digit, we have 2 digits, could be anything from 1 to 10, and it didn't say they couldn't repeat, so the second one would also be 1 to 10, and 10 times 10 is 100 possibilities. Okay, so far we've been looking at independent events. Like I kind of said, they could have repetition, that made it independent. If they could not have repetition, that becomes a dependent event. With dependent events, the outcome of one event does affect the outcome of another. The fundamental counting principle still applies. This is highly theoretical. They said, how many different schedules could a student have who is planning to take 4 different classes, assuming that each class is offered each period? That doesn't happen even in large schools, but that's the assumption they gave us. Well, first period, you could have your choice of all 4. You've already picked a class, so now you have 3 left, 2 left, 1 left, and we're going to find the product. So 12 times 2 is 24. If the outcome of an event does not affect the outcome of another event, the 2 events are independent. Tossing a coin and rolling a die are independent events. If the outcome of an event does affect the outcome of another event, the 2 events are dependent. Taking a piece of candy from a jar and then taking a second piece without replacing the first are dependent events because taking the first piece affects what is available to be taken next.